Welcome back. You may or may not be watching this immediately after watching video 1. If so, I don't know if that's good or not. You will have to decide. Okay, so we're going to show the next main approach that I use for solving mathematical problems, which is if just writing doesn't seem to pan out, maybe I should actually think ahead. And thinking ahead usually involves really imprecise things that are not part of your proof. Scratch work. So I touched on this in class. I'm going to just talk about it a little bit more now. I'm a really verbose guy. So let's talk about it. So here's an example. Prove there is an x. Now remember our convention, if I say there is an x, I usually mean a real x. There is an x where x minus x squared is greater than 0. Now, that may or may not be obvious depending on what you know about parabolas and polynomials and stuff. It's a little bit weird. You can't pick just anything because you would expect x squared in general to be bigger than x. So that means this minus this should be negative, which we're going to find an example where that's not true, so it's not going to be the first thing you think of. But it'll probably work. So proof, let's try the just start writing approach, and I immediately have no idea what to do. Cool. Our first order sentence was there exists an x such that x minus x squared is greater than 0. I know I need to start with let x, but it says exists, so it's going to be let x equal, and now I don't have a plan. So this isn't going to work. The just start writing approach doesn't work here very well because I ran out of stuff to write before I got to the end. So that's a failure of that approach because it's not very robust, actually. It's not very good. But what's cool is that we actually know some stuff. This here is something that you have worked with before. X minus x squared is a parabola. Right? I mean, it's a polynomial of degree 2. It's a parabola. We know what those look like. We can actually graph them. And we know what greater than 0 means. That's the part where it's above the x-axis. We can graph it and look and see where that happens. So let's graph this thing. So let's think about this in terms of concrete terms. We want to find when is the parabola, right? In scratch work land, when is the parabola x minus x squared greater than 0, when y equals x minus x squared is positive. Okay? When means find an x, positive means find a y. So, you know, the first step to graphing these things is to find the zeros. So we're going to say find x minus x squared is equal to 0, factor out an x, you get x1 minus x is equal to 0. And now that means that x is equal to 0 or x is equal to 1. Now notice something here. If this was a proof, this would be a really bad proof because I've assumed the conclusion. Or actually, I've assumed the conclusion is false. I've assumed something bad. I have no idea whether or not this is true in proof land because it's probably not true. It depends on what x is, and I didn't say what x is. So I just did it. I just wrote some stuff, and it's okay to just write some stuff when I'm in scratch work land. So in scratch work land, I can just start writing stuff. And now that I've done that, I know that my parabola is going to have zeros here and here. 0 and 1. I also know that the big term here is less than 0. The quadratic term, big term, is negative. So this is going to be a parabola that opens down. Okay? Well, if it has zeros here and here, and it opens down, then it's going to go down. And it's a parabola, so it looks like this. Cool. And so the answer should be here. Okay. So actually what we've learned is that x minus x squared is greater than 0 when x is between 0 and 1, but not exactly. Now the proof of this would actually be a little bit complicated now that we know the answer, but all of this, we've done a lot of stuff here that is not precise. We used the word parabola, which we've never defined. We talked about graphs, which doesn't make any sense with any of the formalism we've talked about. Really hard to express. But it has given us some information that we believe to be true, that somehow the answer is this. So when I get back over here and I want to say let x be something, I expect that the best answers are going to be the ones between 0 and 1. So I'm going to use that information. I'm going to say let x equal 1/2. And I'm going to believe my scratch work. I'm going to believe it even though it's not precise. It's good math, but it's not a proof. It's not precise math. but it supports the proof. So now that I suspect that it's going to be 1/2, I just have to show that it works. So then x minus x squared is equal to 1/2 minus 1/4, which is 1/4, which is greater than 0. And you're done. Cool. So in theory, I could have just done this. I could have just said, well, yeah, 1/2, that sounds about right. Done. Cool. And there's a million other ways you could do this. This proof, though, is not very helpful. We don't learn anything from this except that the statement is true. That's not necessarily bad. I mean, the proof's objective is to show that the statement is true, and it certainly does. Exists x such that blah, blah, blah happens. Well, this x works. That's the proof. Ultimately, that is the proof. But the scratch work is where 1/2 came from. And none of this is precise, but that's okay, because it led to something which led to a correct proof. And none of this has to be right. It could all be completely wrong. It could be randomly generated noise, but if at the end I got this information, which allowed me to make this, then I would be right. I would have a correct proof over here. And so the purpose of the scratch work is to support the proof. The purpose of the scratch work is to guide the proof. If you don't know what to write, but you do recognize something over here that you understand concretely because you're used to it, then you can use your loose understanding, your imprecise understanding, to get precise information that you can then use to write a proof. Okay? So that's the main other way. When just write stuff doesn't work, when there's not enough stuff to just write, then this sort of understanding can be really helpful, and it leads to a correct proof. Okay, so I hope this video was informative, and again, post your questions in the comments, emails, personal questions, whatever, I don't care. See you on Monday.